Welcome to Developer Service YouTube channel. On today's episode, we're going to be talking about why equals and is are not the same when doing comparisons in Python, and how that can lead to some hidden bugs. So let's start with a simple example. I have two lists here, list A and list B. Both of them have the same values, 1, 2, 3 inside the list. So let's see what happens when we do equals. So running the code, you see A equals B, that is true. And it is true because the same values in A are present in B. So if we change, for instance, for a 4 here and run the code again, obviously now it's false because A is no longer equal to B. So equals compares the values. So reverting the list back to the original value, so A and B are both 1, 2, 3 and 1, 2, 3, so A and B have the same values. We are going to be doing again the equals, and this we're also adding the comparison with is. So let's run the code. So A equals B, that is true, and A is B, that is false. And why is that? Both of them have the same value. So y is equal true and y is false. So A equals B, it compares the values. So in this case, the values of A and the values of B are the same. But A is B compares the objects. So it compares if the object A is the same as object B. And even though there are a list with the same values, they are not the same object. And let's see how we can see that. How can we see that they're the same object or not the same object? Well, we can use the ID in Python and passing in an object. It will give us the identifier of that object internally in Python. Let's run the code. So we see A equals B true, A is B false, meaning they're not the same object. And we can see that A is object with this number and B it's the object with a completely different number. That's why is does not return the same result as equals, because equals compares the values and is compares the objects. So in this case, A and B are not the same object. But of course, Python will not be Python without its quirks. So let's take a look at another example. In this case, we're assigning to A equals none. And let's see what happens when we, for instance, compare A equals none. Let's run the code. So A equals none, it is true. Even though A and none are also objects, when you're comparing the value in this case with equals, that compares values, the value of A and the value of none, both point to the same object, which is the none object. So that means that if we run the comparison also A is none, and we run it, both give true. So A equals none is true and A is none is true. In this case, the value comparison of equals between A and none, it is true because it is the same value. The object comparison of A is none, it is also true because A is the same object as none, because A is pointing to none. And we can easily check that by getting the identifiers for both A and none. And if we run the code, we can see comparison true for equal and true for is. And if we see our object A points to this value, and none, which is also an object, points to this value. So in this case, for comparison with none, equals and is will return the same value, but fundamentally, the recommended is to use is because that is comparing the object and none is an object. Equals, in this case, gives a correct result, but there is no guarantee in future versions of Python that it will still give a correct result. So as best practice, when comparing to none, always use is. And as a final example, let's see another one of Python's quirks, which has to do with strings. In this case, we have the string A, which is equals to hello world, and the string B, which is also equal to hello world. So let's see what happens. So if I compare it with equals, let's run the code. So A equals B, it is true. And it is true because the string has the same value. If I would remove some element from the string, A equals B, it is false. And if I put it back, A equals B, it is true. So again, equals compares the values. So the value of string A and string B, it is the same. So from my previous description, I mentioned that is compares object. So as we saw, for instance, for the list, you would be expecting that A is B would be false. But let's run the code. And surprisingly, A is B is true, even though they're two different objects, or in principle they should be two different objects because they're two different variables and two different strings. A is B returns true because they're in fact the same object due to how Python optimizes memory. And we can see that by checking the IDs of both A and B as before. So again, A equals B true, A is B surprisingly true, but you can see that that happens because A and B are the same, pointing to the same object, which in this case is the string hello world. This happens because Python does what it's called interns the string. So it optimizes memory by keeping just one object that points to the single string. But this is only true if it's for a short string. Let's now change, and I'm repeating the string hello world for 100,000 times. And if I run the code again, you see that now a equals b, it is true, because in terms of value, both strings a and b have the same value. But now a is b returns false. And why is that? You can see by getting the IDs of a and b. So the ID of b is this, and the ID of b is this one, two completely different IDs. So what Python does for the short strings by interning them and optimizing the memory by just keeping one single instance of that string, the same is not true for long strings. For long strings, Python creates two different separate objects. As you can see here, that object A and object B have two different IDs. So that means that A is B, which compares the objects, returns false, even though A equals B is true, because they do have the same value, but they are pointing now to different positions in memory. So remember, equals and is are not the same. Equals does value equality, meaning it checks if the objects have the same value. This can be a list that has the same components inside, can be a string that has the same value. It does not matter. It compares that the value is actually the same. Is, it has identity equality. That means it checks if the objects are the same object. So whether it is a string or an integer or a list, it checks if they point to the same memory position. Most of the times they will be pointing to different memory positions because they're different objects. Exceptions are, as we see, that the none points to the same memory position if it is assigned to a variable. And also short strings, the way that Python optimizes memory, are also pointing to the same string object in memory. Like this video if you like this content, subscribe for more content about Python, Django, and AI. And until next time, happy coding!